Let's talk about displaying categorical data. This table shows the number of people who survived and the number of people who died in the sinking of the Titanic on April 15, 1912. It's called a frequency table because it shows the frequency in each category. So for example, first class. This column shows what happened to first class passengers. There were 325 first class passengers overall, 203 survived, 122 died. What percentage of first class passengers survived the accident? Round to one decimal place. Well, of the 325 first class passengers, 203 survived. 203 divided by 325 is 0.6246. When we represent that as a percentage, we get 62.46%, or, rounding to one decimal place, 62.5%. What percentage of third-class passengers survived the accident? Round to one decimal place. Well, of the 706 third-class passengers, 178 survived. 178 divided by 706.2521. When we write that as a percentage, we get 25.21%, or in other words, 25.2%. Notice that a much lower percentage of third-class passengers survived compared to first-class passengers. Now let's just look at the number of passengers in each class. Okay, overall, 325 in first class, 285 in second class, etc. Makes up a total of 2,201 passengers. There's some dispute about how many passengers there are. Some have it a little higher, some a little lower. Let's just look at the percentage of passengers in each class. So, for example, in first class, 325 divided by 201, 14.8%. So 14.8% of the passengers were first class. 285 second class out of 2201, that's 12.9 second class passengers. 32.1% in third class, and actually 40.2% of the passengers were crew. Okay, now what we have here is a frequency table. If instead of using the raw numbers, you use the percentages, you'd get a relative frequency table, because this tells you, relatively speaking, what percentage of passengers were first class, what percentage were second class, etc. This is a relative frequency table. We can also represent these data in a pie chart. Also, offhand, notice that data is a plural. We don't say we can represent this data in a pie chart. That sounds ignorant. We can represent these data in a pie chart. Okay, so here we have a pie chart. The light blue is first class, red is second class, orange is third class, and blue is crew, blue crew. Okay, we can use a pie chart to demonstrate this or to illustrate this because the data are percentages that add to 100% or are a count of something. So whenever you have data that are percentages that add to 100%, or you have data that are a count of something, like counting passengers, you can use a pie chart. Also, there's no overlap in categories. We could not, for example, use a pie chart if some people were both first class and second class. That doesn't make any sense. We can also represent these data in a bar graph. Okay, same data, but here we're representing them differently. First class, second class, third class, and crew. So we can also represent these data in a line graph, but it looks stupid because in line graphs, the horizontal axis usually represents time, not moving from first class to second class to third class to crew. So a line graph is a bad idea in this case. Okay, let's talk about pie chart versus bar graph, or bar chart, sometimes we call it. Notice that one advantage of a bar graph is that you can more easily compare two categories. So for instance here, you can see that there were more crew than third-class passengers, whereas here, it's not as easy to see. It's a little, they look equal, roughly equal. Ditto with first class and second class. It's a little tough to tell that there was slightly more first class than second class, but it's relatively easy when you use the bar graph. By the way, did you know that the last survivor of the Titanic died in 2009, 97 years after the ship sank? Melvina Dean was 2 months old when she sailed into the Titanic, and she lived to be 97, which means that she was around when that movie Titanic was made with Leonardo DiCaprio.